It's what your mom taught you about AI.
What?
In this episode, you'll learn about the 3 trends we're seeing as we talk to customers in the field of mobile robotics and AI. But first, Ian, can you tell me what you learned about AI from your mom?
Okay, well, when I was a kid, all I was left to roam the streets on my BMX bike, and all I was told is be home at dark. Perhaps that's the same lesson. Make sure you have boundaries, but let your AI do what it needs to do and explore the world and, make sure, it's a new field. There's all sorts of exciting things going on. You want to let it explore in the real world and do its thing, but keep some boundaries around it and make sure it's home at night.
Makes a lot of sense. Your mom needs to make sure you're safe, and we need to make sure we're doing mobile robotics and AI safely.
Correct. Yeah.
Okay. So you're going to learn about the top 3 trends we're talking about with our customers around mobile robotics and AI. So to start with, Altaf, what is the first thing that comes to your mind about a key trend in AI in mobile robotics?
Right. So this is a very fast evolving field in terms of artificial intelligence, and especially in mobile robotics, right? One of the new areas that we're seeing is people want to add Gen AI capabilities, agentic AI capabilities to their platforms so that robots are not only able to navigate and get around their environment, but they can also basically take action upon what they see in that environment as well. And that's really what agentic AI is doing. So for example, if you're in a factory or a warehouse and you're seeing a fire or an accident, what action should the robot take? It can basically automatically take like an image of that event, send it to a specific email or a WhatsApp or some other ID, and also turn on like the fire sprinklers or something, depending on what the event is. So you can actually take some action automatically rather than relying on other people and just communicating that information.
So it can use data points in the environment around it to feed the AI engine.
Right, exactly. So it becomes more autonomous. It becomes basically aware of its surroundings, and it can detect different types of events. You still have to tell it about those events and what action you want to take, but you can train the AI to basically do that so that you can get a better solution in terms of managing the emergencies and events that go on in that environment. Right.
Great. How about safety, Ian?
That's a really good question because really today we cannot really say trust that AI will be safe. So it's important, and whenever we're designing it or using AI in one of our systems, we pick parts that have boundaries around it, and we might have a safety monitor part that's also watching what's happening with the main control system. So a robot, no matter what happens with where it's supposed to go, has another processor that's supervising and says, whatever happens, you're not allowed outside these boundaries, or you're not allowed to get this close to something. Those kinds of things need to be capable in the hardware, at the hardware level, like with like on an i.MX 95 board, for example, we have processors that can watch other processors, but they're all in the same chip. And no matter what happens, it can cut the power to the motors or that sort of thing.
Okay, so providing some boundaries.
Yeah, yeah. Boundaries for whatever the AI might be able to do, but constrain it.
Constrain it.
Just like I had to be home at dark.
You see it that way too, Altaf?
I agree with Ian to a large extent on the safety, and AI really isn't used in a safety environment, especially for mobile robotics. But there are other markets and applications that are working on solutions in terms of proving in the market over a long period of time with more predictability of how AI is going to behave in that particular environment. So avionics, for example, aerospace applications, right? For autonomy and those types of applications in that environment, as long as you can prove predictably what the failure rates are and you can manage those, you can still use AI to a certain extent for those safety applications.
Another trend that I hear about, and this is something that I also hear about in other market segments as like the autonomous home or the smart home, is bringing more intelligence to the edge. So, tell us about how you see that applying in mobile robotics.
Just like Althoff, you just mentioned about avionics, and but that's often we think of it on a bigger processor doing, a large aircraft or something like that. But here's an example of one of our i.MX processors. It's got a neural processor attached, and the latest software that runs on it actually has a flight control module that does that calculation using AI, not traditional math or EKFs. And so that's pushing the edge, right? I mean, it's moving that processor, that idea of how to control a small aircraft, or in this case, a drone or a small winged aircraft, all the way to the edge to the microcontroller that's doing that control system. Yeah.
Yeah.
So
And you can get quicker responses, have things happen more real time, not have to go to the cloud and come back.
absolutely, yeah. I mean, it's all local. They're not the same sort of big agentic AIs we talked about earlier. They're like, they know a variety of variables, 5, 10 variables that are still hard to do the math. And if you do a neural processing, a network on that, then you can come up to the solution for things that would be very complicated to code.
And I think about this also when we talk about building a platform and architecting a platform, that one of the things you should really evaluate is how are you going to architect the intelligence aspect? Are you going to do distributed intelligence or centralized intelligence? Altaf, I know you've talked about distributed intelligence before, so does this also tie into this trend that we're seeing?
Yeah, I think it does, because if you look at, the newer devices that are coming out, like we talked about before, the scalability on the MCUs and MPUs, almost every single product that we're developing has AI or neural processing built into it. So all that intelligence is there. It's a matter of, are you taking advantage of it? Are you using all the capabilities of that device to make decisions at the edge and go with a more distributed architecture? Or if you just want to ignore that capability and send everything to the central processing and do everything there. So I think the architectures, the solutions are there. It's just a matter of how you want to take advantage of those capabilities.
It's great learning more about these three trends, but Ian, I see that you have a robotic toy here, and it's always great to get some kind of explanation of how these trends translate into real-world applications.
Sujata, you triggered me here because this is not a toy. That's my pet peeve.
Oh, sorry.
So it's a scaled down model of a real robotic system, and we've got a real-time controller and a companion computer, and it's running T1 automotive 2-wire networking and CAN bus and LiDAR and vision and GPS. So it's way more than a toy. And what's cool about this is we've enabled it with a NavQ Plus, which is a complete reference design you can copy that uses an i.MX 8M Plus processor. And the big thing is, you're running Linux, and it has vision capability, so there's cameras attached. But this chip also has neural accelerators as well as the vision pipelines. There's 2 of them. So in terms of network neural processing or AI, you could, for example, tell this, program this buggy to go and look around for fire extinguishers in a building. And the neural processing, the AI would be analyzing the video stream and do that. So that's a good example of our enablement and pushing it all the way to the edge. And so everything's running locally on this little neural accelerator that's in the Linux machine.
Great. So note to self, do not call this a toy if I want to be on your good side.
Right.
Okay, well, this is all really interesting, and bringing it back to the premise we talked about, what did you learn about AI from your mom? So I know it didn't make sense at first, but now I hope that you have seen what that translates into, and that AI is such a powerful technology that's still evolving. People are learning how to use it, and with that comes responsibility on how to use it.